Our learning objectives for today are use geometric sequences, find the sum of a geometric series, and write repeating decimals as fractions. Let us now look at our first learning objective, use geometric sequences. Hassan sees a new book in a bookshop. He emails a link for the author's website to 4 of his friends. They each forward the link to 4 of their friends. The link is forwarded again following the same pattern. How many people will receive the email on the 8th round of emails? This kind of real-life situation gives rise to geometric sequences. In a geometric sequence, the first term is non-zero, and each term after the first is found by multiplying the previous term by a non-zero constant r called the common ratio. The common ratio can be found by dividing any term by its previous term. So we have a1, which is the first term, r, which is the common ratio, and the formula for nth term of a geometric sequence is given by an equals a1 times r to the power n minus 1. Let us now go back to our original problem where we wanted to find how many people will receive the link on the 8th round of emails. So in the first round, there were 4 emails sent out. In the second round, there were 16 emails that were sent out, and we continue the pattern. So to find how many people will receive the link on the 8th round of emails, we need to first find A1, which is the first term, which is 4 here. Next, we want to find the common ratio, which you can find by dividing 16 by 4. So 16 divided by 4 is 4. Next, we write the formula for the 8th term of the sequence. So we will have A8 equals A1, which is 4, times r, which is again 4, to the power n minus 1. So n here is 8, so this will be 8 minus 1. So we will have 4 times 4 to the power 7, which will give us 65,536. So on the 8th round of emails, 65,536 people will receive the link. Example 2. We need to write an equation for the nth term of the given sequence. So to begin with, we will identify A1, which is the first term. So the first term here is 0.5. Next, we will find r by dividing two consecutive terms. So if I divide 2 by 0.5, I will get 4. And then lastly, I will just write the equation. We have an equals a1 times r to the power n minus 1. So the equation for the nth term would be substitute for a1, which is 0.5, times r, which is 4 to the power n minus 1. It's your turn now. Pause the video and resume when you're ready. Welcome back. You can now check your answers. Well done if you got both the answers correct. Geometric mean. Like arithmetic means, geometric means are the terms between two non-consecutive terms of a geometric sequence. The common ratio r can be used to find the geometric means. Let us now look at an example. Here we want to find 3 geometric means between 2 and 1250. Since there are 3 terms between the first and last term, there are 3 plus 2 or 5 total terms. So n equals 5. Next, we want to find the value of r. We use the formula for the nth term of a geometric sequence to find the value of r. we know AN, which is 1250. We know A1, which is 2. And we also know N, which is 5. We substitute all these values in the formula and simplify. On simplification, we get two values of R, which are positive 5 and negative 5. So when we use the positive value of R and multiply each term by 5, we get the three geometric means as 10, 50, and 250. And when we use the negative value of R, which is minus 5, we get negative 10, 50, and negative 250 as the three geometric means. It's your turn now. Pause the video and answer the question. Resume when you're ready with the answer. Let's check the answer. Well done if you have got both the answers correct.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. The first session is always free. So if you are interested in a free lesson, click the link in the description below. To book a lesson, you can always send us a direct message on Instagram at Mr. Mathematics. Okay, with that said, let's get back to our lesson.
The second learning objective is to find the sum of a geometric series. What is a geometric series? A geometric series is the sum of the terms of a geometric sequence. For example, for the geometric sequence 1, 3, 9, 27, and so on, the geometric series is given by the sum of all the terms of the sequence. The sum of the first n terms of a series is called the partial sum and is denoted by Sn. Let us see how we find the sum of a geometric series. We can find the sum Sn of the first n terms of a geometric series based on what information is given to us. If we are given a1 and n, we use this formula which states Sn equals a1 minus a1 times r to the power n over 1 minus r. Here r is not equal to 1. If we are given a1 and an, we can find the sum Sn by using this formula which states Sn equals a1 minus an times r over 1 minus r. Again, r cannot be equal to 1. We can also write the sum of the series using sigma notation, which is read as summation k equals 1 to n f of k, where this is the first value of k, this is the last value of k, and here we have the formula for the terms of the series. Let us now look at an example which uses the sum formula. Here we want to find the sum of the first 10 terms of the geometric series with the first term 2 and common ratio 3. We will solve this example in two steps. The first step is to write what we know. So here we are given 10 terms, so n is 10. First term is 2, so a1 is 2. Common ratio 3, so r is 3. Now we have to use one of the partial sum formulas. Here we are given a1 and n, so we use this partial sum formula a1 minus a1 times r to the power n over 1 minus r. Next we substitute all the values, so we find S10 equals 2 minus 2 times 3 to the power 10 over 1 minus 3, which on simplification gives us 59,048. Now let's look at an example using sigma notation. We want to find the value of summation k equals 3 to 10, 4 times 2 to the power k minus 1. To begin with, we need to find a1, r, and n. Note, the value of k here starts from 3. So in order to get a1, we substitute 3 in place of k. So we get 4 times 2 to the power 3 minus 1, which gives us 16. The base of the exponential function is r. So this term here is r, so r is 2. And there are 10 minus 3 plus 1 or 8 terms, so n is equal to 8. Next, we choose the formula for the partial sum and we substitute the values, and on simplification, we get the value of Sn to be 4080. It's your turn now. Pause the video and resume when you're ready. Let's check the answers. Well done if you got both the answers correct. Next, we look at an infinite geometric series. An infinite geometric series has an infinite number of terms. A series that has a sum is a convergent series because its sum converges to a specific value. A series that does not have a sum is a divergent series. For example, let's look at this series. If you notice, each term is getting smaller and smaller. This is an example of a convergent series. Here we have the absolute value of r, which is the common ratio, to be less than 1. And a convergent series always has a sum to infinity. The formula for sum to infinity is given by a1 over 1 minus r, with the condition that the absolute value of r is less than 1. If I want to find the sum to infinity of this series, I will look at the first term, which is 1 over 1 minus r, which we can get by dividing the second term by the first term, and we'll get 0.5, which on simplification gives us 2. In case of divergent series, let's look at this example. As you can see, each term is getting bigger and bigger. And if we want to find r, we get 4 divided by 2, which is 2. So here the absolute value of r is bigger than 1, and the divergent series have no sum to infinity. So whenever we need to find the sum of an infinite geometric series, we first check whether the absolute value of r is less than 1 or bigger than 1 and decide whether it's a convergent series or divergent series, and then use the formula to find the sum in case it's a convergent series. Let us now look at an example where we want to find the sum of each infinite series if it exists. The first example is 2 over 3 plus 6 over 15 plus 18 over 75 plus so on. To begin with, let's find the value of r, which we can find by dividing the second term by the first term. So we divide 6 over 15 by 2 over 3. This gives us 3 over 5, which is less than 1. That means this series is convergent and sum to infinity exists. So we write the formula sum to infinity is equal to a1 over 1 minus r. So the first term here is 2 by 3. So 2 over 3 divided by 1 minus 3 over 5, which on simplification gives us 5 over 3. Now let's look at the second series here. Again, we first find the value of r by dividing the second term by the first term. This gives us 1.5, which is bigger than 1. So this series is divergent and sum to infinity does not exist. It's your turn now. Pause the video and resume when you're ready. Let us now check the answers. Well done if you got both the answers correct. What is a repeating decimal? A repeating decimal is the sum of an infinite geometric series. For instance, 0.45 recurring is equal to 0.454545 and so on, or 0.45 plus 0.0045 plus 0.000045 and so on. If you observe, this is nothing but an infinite series, and we can use the formula for the sum of an infinite series to convert the decimal to a fraction. For example, we want to write a repeating decimal as fraction. Here we want to write 0.63 recurring as a fraction. So to begin with, we write 0.63 recurring as 0.636363 so on, which can be written as a series as 0.63 plus 0.0063 plus 0.000063 plus so on. Now this is an infinite series, and we know that the sum of an infinite series is given by a1 over 1 minus r. So here a1 is 0.63 and r can be found by dividing the two consecutive terms. So 0.0063 divided by 0.63 gives us 1 over 100. Now let us try to find the sum. This will be equal to a1, so 0.63 over 1 minus 1 over 100. So here this can be written as 63 over 100, and the denominator simplifies to 99 over 100. So here this gets cancelled. We get 63 over 99, which can be simplified to 9, 7 over 11. So we have written the recurring fraction 0.63 recurring in the form of a fraction as 7 over 11. It's your turn now. Pause the video and resume when you're ready. Well done if you got the correct answer.